Hey, it's Friday. Yay, yay. It's the last day of the week. We are almost done with Module 3. You are becoming subtraction ninjas. The last thing we need to make sure you know how to do for this week is you know how to subtract fractions, making sure you have like units. We've done this quite a few times. I'm going to show you a basic one. I'm going to actually make sure you understand the butterfly method one more time. So let's do 3/5 minus 1/6. When you look at that problem right off the bat, you should say, I cannot do it unless they have the same denominator. And then right off the bat, you should be like, well, what I'm doing is I'm formulating a new problem, right? And when you're formulating a new problem, you are immediately drawing new fraction bars because you are saying, I need brand new denominators. And then to do my butterfly, I'm going to first give my butterfly a ground to stand on. Let's pick the pretty ones. I'm going to give my butterfly a ground to stand on by going 5 times 6 creates the ground, right? So 5 times 6 is 30. So the new ground that my butterfly gets to stand on is 30. I'm going to give my butterfly a body by remembering to bring my subtraction sign down. That's what that body part is. And I'm going to give my butterfly its wings by going, I'm multiplying these two numbers. I'm multiplying these two numbers. There's my butterfly. This is the butterfly method. And it only works if it only works if the multiplying the two of those together does give you the lowest common multiple. You need to understand that you can't always do a butterfly, but it will work in an emergency. So 6 times 3 is 18. 5 times 1 is 5. Now, it's a good thing that I gave my butterfly a body and I remembered that I'm subtracting. 18 minus 5 is 13/30. I know that by now you are some kind of ninja expert at doing a problem like that. So let's look at a problem more like this. And there are several ways to solve this example number 2 that I'm going to show you. We're going to subtract 1 3/4 minus 3/5. Okay? Now, there's a couple different ways that we can do this. We can remember that 1 whole is really 5/5 or 4/4. So really what I have is 5/5, 3/4 minus 3/5. Now that looks kind of weird when you first look at it, but 5/5 and 3/4 makes it so that I can combine these two. Remember before when we were combining combining the whole numbers? Well, I can combine this and this. I can do 1 and 3. Basically, I'm doing 1 minus 3/5, right? So 5/5 minus 3/5 gave me 2/5. And then I have to put my 3/4 back on because the 3/4 already existed on there. Let me show you on a number line. I was not at 1. I was actually at 1 3/4, right? So I was at 1 3/4, and then I subtracted 3/5. So I'm going to go back here somewhere. So here I have to go, they need to have a like denominator. I'm going to make them 20 because 5 times 4 is 20. 4 times 2 is 8. 5 times 3 is, my brain went. 5 times 3 is 15. 8 plus 15 is 23/20, which is 1 3/20. Oh, I might drew my arrow too far here. Okay, that's one way you could do it, is consider that. That's just method 1. Oops. Which took a lot of space on my paper, more space than I planned. Now let me show you method 2. Here's another way to solve that same problem. And I'll be honest, this is the way that I prefer to solve it, is to see that I have 1 3/4 minus 3/5. I'm going to keep my 1 way out here separate, and I'm going to work on common denominators, right? So I need them to be 20ths, I can do what I did up here on my butterfly method, right? So I can 4 times 5, 5 times 3 is 15. 4 times 3 is 12. My butterfly body is subtract. And now I have 15 minus 12 is 3/20. So then I'm going to put my 1 back on, and I have 1 3/20. So that's another way to solve that same problem. I'm going to show you one more way to solve the same problem. Same problem. 1 3/4 minus 3/5. Seeing it okay? Yeah. Zoom it in so you can see all right. 1 3/4, I can really go 1 times 4 is 4 plus 3. So I here have 7/4, right? I'm just going to incorporate the whole right into make it an improper fraction. So now I have 7/4 minus 3/5. Split this out and show you that this is method 3, right? And again, they're 20ths. They're still subtracting. But this time I'm going to go 5 times 7 is 35, still butterflying. 4 times 12, 4 times 3 is 12. 35 minus 12 is 23/20, which is really 1 3/20. So there's 3 different ways you can do that, and it's all about whichever feels the best and easiest to understand for you. Go ahead and make your notes match mine, and then I'll show you another example in your problem set. All right, so in your problem set, when you're thinking about the ones that I had just shown you, what I'm saying is, well, I expect that ones like A and B, you should know how to do, and C quite easily. Let's look a little more at something like D or even G, right? So for G, what I personally would do is I personally would go like this. 5 minus 2, I'm going to separate those out. That gives me a 3. And then I have 7 and 3. They have to have a new common denominator, a lowest common multiple of 21, right? So I have 3 is totally separate, like not from what's going on right here. And then, but I do know I have 3 wholes in the end. And then 6, let's see, 3 times 6 is 18. 7 times 2 is 14. I'm subtracting, which leaves me with 3, and 18 minus 14 is 4/21. So the difference is that we have to remember that this 3 didn't get brought all along the problem. It just gets brought down to the bottom, because you're dealing, once you've isolated the whole numbers, you're dealing with the fractions separately. So it's like a subtraction of wholes and then a subtraction of fractions, and put it all back together, or add them together, put it all back together. Go ahead and do page 39 and 40. We will be meeting in small group if you have any questions on this one. And I'll see you in small group.